Hello everyone, my name is Umi Fahmida from Senior Regional Center for Food and Nutrition at Universitas Indonesia. On this online summer course, which is Diponegoro course on child nutritional aspect in coastal region, I'm happy to share with you what I have been working with in over the past 10 years on linear programming for designing food-based intervention. And at the end of this course, I hope you can achieve the following learning outcomes, which are terms related to FBDG, FBR, and GFR, and then how you can make use of the linear goal programming or the LP approach, particularly what data is required to develop FBR or GFR using LP, the so-called LP input. You can identify problem nutrients, type of problem nutrients, and dietary inadequacy in the diet. You know how to identify nutrient-dense food subgroups or food items. And finally, to select the best alternative FBRs or GFRs for final patients. And the outlines, I will start with the terms explanation, the LP approach to identify problems and solutions. And I have also provided you the papers and readings on the concepts of LP and the example of how to develop CFR and also to evaluate GFR intervention and an example of application for disease prevention. So what are the terms? First, FBDG, some of you have been quite familiar. It stands for Food-Based Dietary Guidelines. And food-based dietary guidelines, if you look into FAO website, for example, are sets of recommendations which provide advice on foods, food groups, and dietary patterns in order to provide the required nutrients to general public to promote overall health and prevent chronic diseases. So the aim is to give message to the people in terms of food instead of nutrients. And FBDG are usually quite generic. It is countrywide, while to translate further into more specific subpopulation, FAO also suggests that we can further develop more population-specific recommendation. And when we develop using the linear programming approach, the most commonly used terms now are FBR, which stands for food-based recommendations. And when the FBR is developed for under 2-year-old, it is called GFR, which stands for complementary feeding recommendations. And let's take a look into the requirement for FBDG. You know that for the messages to be called good FBDG, it has to be scientifically sound, involve stakeholders involved. At the same time, it should be short, clear, easily remembered, and culturally appropriate statements, and support practical, affordable, flexible, and accessible, as well as close to the current practices so that it is easy to implement. And then finally, FBDG should consist of concrete statements, usually maximally of 7 messages, which can be qualitative and quantitative version. And in development and refinement of FBDGs, usually it will start with government forms working committee, and then this committee will continue to collect data on nutrition-related diseases, food availability, and intake patterns. And based on these major nutrition-related health problems, the committee will decide to develop the FBDG and draft the FBDG. Based on this, then in the refinement stage, the background statements for each guideline reviewed and discussed, and wording of the messages will be tested with consumer groups, target groups, and this group will review the FPDG before finally the committee revises the FPDG. And as you can see on the left panel, these are the traditional approach when FPDG is developed using steps of so the committee working with empirically propose a diet, and then they will check the nutritional composition of the proposed diet, if it is adequate, if it is feasible, and if it is not, then we will go back. They will go back again to identify what is the best diet that corresponds to the nutrition and health problem and at the same time is feasible. Now, how linear programming can help is that because in the linear programming, which is goal programming, where the goals are energy and nutrient requirements, RNI, and the constraints are the food patterns, the food list, which are the food available, and also the food portion. So this mathematical modeling can be used to find the best combination of diet that can meet as much as possible the energy and nutrient requirement. And because this is a mathematical modeling, it can be quite quick to develop several 20, even more than 200 alternative combination, which can then be further tested. So as you can see here, it really saves the time for the step of trial and error of finding and testing one combination at a time of the diet. So in particular, when you use the LP to develop optimized GFR or FBRs, you will need what we call the LP inputs. And as you can see here in the yellow box, the LP inputs consist of the list of the food items which are locally consumed, along with the food portion, usually with the median portion size of each food, and then the food pattern expressed as the frequency of consumption per week, and optionally you can also have the food cost, which is the cost per gram edible portion. And then with the OptiFood in module 2, which I will show later, then best combination diet, the so-called two best diets, will be identified, and this best diet will be further tested for its robustness in module 3 by minimizing each nutrient at a time. And the purpose is to make sure that while the best diet meets the RNI, the worst case scenario, the minimized diet, will still stay above the EAR, or estimated average requirement, which is the median of the nutrient requirement. And if these EARs are fulfilled for all nutrients, basically the EAR is around 65 to 70% RNI, then optimized local specific FBR or GFR can be developed. In many cases, it may not be straightforward, and in some cases, when some nutrients have worst case scenario or minimized scenario less than EAR or 65 to 70% RNI, then this is where the LP can help to further identify the nutrient-dense food or subgroups, and then to put it into alternative combination of GFR and FBR, and then finally then we can choose the best one that fulfill the most nutrient requirement for the most nutrients. And at the end, the trial of improved practices can also be used, basically to ask a small group of people to test whether they can practice the recommendation after they trial it for one. So in more detail, the slide shows the data required, the LP input. These are the list of foods consumed by target group that you can obtain from the dietary data. And for each food, you will, of course, need the nutrient composition or food composition table, the FCT, the portion, we usually use the median, the frequency of consumption per week, which are the minimum and maximum. We sometimes use 5th or 10th percentile as the minimum and 90th or 95th percentile as the maximum. And if you like to model cost, you also need the cost per 100 gram edible portion of each food. You also need to have the food pattern of the target group in terms of how many meals, how many snacks are consumed per day. And if you do diet modeling for under 2-year-old children, of course you need to have breastfeeding status. In most cases, if you make a recommendation, of course we will have the data developed for breastfed children, and in this case you also need to have breast milk as one of the food. And of course you need to establish the goal, and the goal can be the FAO recommended nutrient intake, or you might use your own country specific RNI, such as Indonesia's may use the Angka Kecukupan Gizi or AKG. And then finally, of course, you need to inform what will be the energy and protein requirements for the target group. And in this case, you will need the median body weight information of the target group, or alternatively, you can also refer to the requirement of energy and protein for the particular age group. All this data can be obtained from dietary data. Of course, if circumstances allow, such as in the study, it will be ideal if you can have 7-day, 1 full week data for each respondent. While if not, you can make use of the 1-day data, preferably with a bigger sample, and from the percentage consumers of each food, there is a method, actually a conversion factor, to convert the percent consumers into days per week of consumption, which can then establish the food pattern. If you have more than 1 day but not 7-day data, you can also use that. For example, a food frequency questionnaire. The key is that you will be converting the information into frequency of consumption per week or meals per week. So in summary, if you can see this table, there are 3 levels of information required in the LP input. One at the food item level, and then the food items can be grouped into food subgroup, and the same food subgroups can be grouped into food groups. For example, food item can be fermented soybean or tempeh, and then the food subgroup is soybean and soybean product, while the food group will be legumes. Or another example is liver as a food item, and food subgroup is organ meats, and the food group is meat, fish, and poultry. So the food groups and food subgroups should follow the one that are already categorized in the OptiFood software. And for the food item, of course, you need the portion as gram per meal, or gram per day, or gram per meal, depending on what you model. And then the minimum and maximum frequency of consumption per week. And in addition, you need to inform the OptiFood about the food, whether it is a snack, whether it is a staple, or both or none. And an example is like rice is usually only a staple. Cassava can be both staple and snack. And fruit is only snack but not staple. And a protein food in most cases are not snack nor staple. And for the food subgroup and the food groups, you will need the minimum and maximum frequency per week. Plus, in addition, for the food groups, you also will need the average frequency of consumption per week, which will set the basis of FP, or food pattern diet, in the two best diets. So in the OptiFood, then you will have the inputs for the food items level, and then for the food groups and the food subgroups level. So when we start with the OptiFood, it means we have managed to get all those information. I usually use the LP inputs using a simple function in the Excel. You can also use Access, for example. And using Excel, it is straightforward. From the dietary data, you will establish that each row will consist of the food items and each column will consist of the subjects. And then you can make use of the pivot tables, for example, or functions to calculate percent consumers in order to get the LP inputs, as I have mentioned earlier. And then when you are ready, then you put them all into a table, which you will save into CSV format, because the OptiFood software reads CSV, and they can also export the result into CSV, which you can open later in the Excel. So once you are ready with the LP inputs, then these are the steps in the OptiFood. Start with creating a target group, entering food and diet data, which are your LP inputs that you have summarized from Excel or Access. And then you will check the data entered to see how feasible it is to create a feasible diet. And finally, you will perform the LP analysis. And as you can see there on top, the reference data inside will include the food composition. There are food items already with the composition inside the OptiFood, but you can add, of course, additional foods if the foods you need are not yet inside. And then there is also nutrient recommendation. The default will be the FAO RNI, but you can also enter your user defined nutrient recommendation, for example, angka kecukupan gizi. And these are the nutrients which are in the default of the OptiFood that can be optimized. And the requirements of these nutrients, as mentioned earlier, of the macronutrients, A, B, C, vitamin, and folate, and calcium, iron, and zinc are obtained from the FAO RNI. So the slide shows the target group details, which is the first step in OptiFood, where you need to inform about the group. So you can give the group a name, for example, under 2 in Central Java, rural area, for example. And then you can define whether you will model cost or not. If you click yes, then the OptiFood will ask what will be the maximum cost per week that you allow the diet. And then you specify the country, the region, the RNI authority, whether you want to use the OptiFood, which means FAO RNI, or you want to use the user-defined, such as your country-specific RNI. Then important thing is also you will choose the RNI group, which is the demographic. For example, here it is adult female 19 to 50 years old. And then you will define the average weight, and automatically based on this, OptiFood will identify the recommended energy requirement and protein requirement. If it is adult, you also need to add the assumption of the physical activity level, whether light, moderate, or heavy. And the last 2 points are also important, in which you need to define what is the right assumption of bioavailability for iron and zinc given the food pattern. For example, for typical Indonesian, because we still consume quite some amount of animal protein, but not too much, so I usually put the assumption of iron as 10% and the zinc as moderate. So once you have all those information, the first step will be check diet. And in this module 1, the purpose is to check whether the model can be generated to come up with a realistic diet and whether any changes are needed to the model parameters to make diet realistic. This shows example when diets feasible. As you can see, the energy range from 77 to 200, over 200 energy requirement, which is just showing that when all feasible combinations are tested, trialed, the energy range are that big, and that usually shows that you have enough food on the list with adequate food pattern, the frequency and portion that allows the diet to choose a different combination of foods. And if this is the result, then you are ready to proceed with the LP inputs and you can log data and continue with the next step. In the case that you come across with this example, saying solutions are not possible, as you can see here, the energy range is quite narrow compared to before, which is usually an indication of probably too few foods on your list, or the food patterns are not big enough to allow more combinations, and also the food portion may be mistaken, maybe the unit. And usually with more samples, you will capture more representative pattern, more appropriate number of food lists, and you can come up with the feasible solution. So when you don't have a feasible solution, take a look, make sure the food list, the food patterns are quite sufficient. Usually a number close to 100 foods are resulting a feasible solution. And one more thing is that in OptiFood, you should not be using the same food item in 2 rows. So it should be exactly specific, and that also helps you to avoid the problem of non-feasible solution. So when it is feasible, then you are ready to go to the real LP analysis, which is in module 2, to identify draft recommendations. And here you can answer the following question: whether nutritionally adequate diet can be promoted given local foods and food pattern. You can identify the best food sources of nutrient for this target population. You can identify the nutrition and cost implication of selecting recommendations that deviate from population average food pattern, the so-called non-FP diet. And you can also get the clue of what alternative food-based recommendations should be tested in module 3, given the nutrient-dense food group, food subgroup, and food items. Take a look. So the main result in module 2 are 2 best diet. As you can see here, in this module 2, if you click show nutrient graph, you will see for each nutrient 2 bars. The blue one is the percentage RNI achieved with combination of food which is close to the median frequency per week of the food group. While the second one, the orange, are when the combination may deviate from median frequency per week of food groups. The first one is called food pattern, and the second one, no food pattern. And as you can easily understand, the no food pattern will usually come out with a higher percent RNI achievement. So how do you use this information is that you look into the no food pattern, the second bar, and when the alternative combinations allow to meet the 100% RNI, it means the nutrients are not problem nutrient. In other words, if it fails to achieve 100% RNI, then these are the problem nutrients. In this example, you can see calcium, iron, and zinc are problem nutrients. So once you identify those problem nutrients, you can go to the module 3, and here you can test food-based recommendations basically, and here is the place where you can identify the minimize or the worst case scenario and the maximize or best case scenario of each nutrient. This is where you can compare set of alternative recommendations, and this is where you can also test finally with all the alternative combinations are FBR likely to ensure that all nutrient needs. So this is how it looks, the module 3, and you can see two bars now. The blue ones are when each nutrient is minimized or worst case scenario, and the second bar, the orange, is when the blue bar when the nutrient is maximized, yeah, the orange bar, and in other words of this orange bar is the best case scenario. The difference between this module 3 and module 2 is that module 2 shows a diet, so simultaneous combination of all the foods, and then it gives a achievement of RNI for the nutrients altogether. While for this module 3, it is basically some kind of like sensitivity analysis when you want to see the lowest possible level of each nutrient and the highest possible level of each nutrient. So we minimize and maximize one nutrient at a time. So this is not a diet, but this is more like a worst and best case scenario, how low and how high each nutrient can go in the more extreme modeling. So for example, we want to know how low iron can go regardless of other nutrient, and how high iron can go regardless of other nutrients. Yeah, and there are two information that you can get here. First, if you see the maximize or the orange bar, you can see here if previously in module 2 nutrients are identified as problem nutrients, you will give a further trial. What if we maximize it? And if we maximize it and it can meet 100% RNI, it means the problem nutrients are partial. However, even after you maximize it and it fails still to achieve 100% RNI, it is called the absolute problem nutrient. And as you can see here, calcium, iron, zinc are the previously identified problem nutrients, and here they also fail. The orange bar are still below 100%, which confirm that these three nutrients are all absolute problem nutrients. Now, how about the other nutrients which are not problem nutrients? So further in this model, you can also check the minimize, the blue bar, or the worst case scenario, and this tells us about dietary inadequacy. The idea here is that when a nutrient is safe, even when you minimize it, it will always stay above the adequacy level, which is the estimated average requirement. So imagine EAR as the median. When you see in your mind a normal distribution of nutrient requirement, RNI is plus 2 SD from the median. EAR, or estimated average requirements, is the median itself. And for most nutrient, the SD is around 15 or 17.5, and so the median is approximately 2 times 15 or 70% RNI, and that's why we use a 70% or sometimes 65% RNI as a proxy of EAR. And here you can see, although, for example, in the blue bar, you can see here the thiamine the riboflavin, the niacin, B6, and folate, they still fall below 70% RNI, and that means they are still dietary inadequate as compared to vitamin C, B12, and vitamin A, which meets the EAR. And so, in summary, using the LP Module 2 and Module 3, for each nutrient, you can identify that they belong to either one of these four categories. The first one, if the best diet is below 100%, then they are called problem nutrients, and the problem nutrients may be partial if the best case can meet 100%, or absolute if the best case cannot meet 100%. And if not problem nutrient, you will test with the worst case scenario, and when the worst case scenario is above the ER or more than 65% RNI, then we call it dietary adequacy. But if it falls below 65% of RNI or below EAR, then it is dietary inadequacy. So these are the mapping of this problem by. An example of the applications is here in the slide. We show you how we map problem nutrients in under 2-year-old from 37 stunting priority district in Indonesia in 2020 with our academic partners. And here you can see that there are variation of the number of problem nutrient across areas, even for the same age group. The red are those with 3 or more problem nutrients, yellow 1 and 2, and green no problem nutrients. And as you can see also on the right panel, there are different typical problem nutrients by age group. The infant has more iron as a problem nutrient, followed by folate and B12, while the older than 1-year-old will have more problems in folate, calcium, vitamin C, and also zinc. So how do we make use of the information that we obtain from Module 2 and Module 3? After we identify the problem, of course, we want to develop the food-based recommendation or complementary feeding recommendation that will meet the nutrient requirement. And using these two modules in the OptiFood, we can actually develop the optimized FBR or GFR using the step of selecting the nutrient-dense food groups, and then continue with the nutrient-dense food subgroups, and if necessary also food items. And then we make use of these nutrient-dense foods or subgroups or groups to compare alternative FBR. The first step in the module 2, when you show the food groups, you will show this table of the food groups along with the recommended frequency per week following the median, which is food pattern, or deviating from the median but still within the range, which is the no food pattern. And the key is that when the food groups are potential to promote, there will be a big gap between frequency in the food pattern versus no food pattern. As you can see here, fruits, vegetables, meat, fish, eggs are the 3 food groups which are potential to be promoted to solve the problem, and this also gives you the frequency per week which can be recommended. And further, you can then, for example, meat, fish, eggs are recommended. Is there any specific subgroups in meat, fish, egg, poultry? And we can make use of the food sources in the module 2. And for example, here for zinc, we can sort a descending order to identify the foods which contribute the most to the zinc. And example here, besides rice, it is meatball and tuna fish. And we define nutrient-dense food as those that contribute to at least 5% of the total intake. And you can do this for food items, and you can also do this for the food subgroups. So finally, with the identified nutrient-dense food subgroups or even food items. You can compare the alternative combinations, and here is an example of typical table in LP analysis. You usually have the top 1 or top 2 rows as the best diet, and then followed by the best case scenario and the worst case scenario. So the first 1 or 2 rows are usually from the module 2, and the next and from the module 3, the best case and the worst case. And following that, you will compare different alternative combinations, and then you will look into which combination give as many nutrients meeting the EAR or around 65% or higher of RNI. Example here are, for our example, where calcium, iron, zinc are problem nutrients, and we compare different alternative combinations of the identified nutrient-dense food subgroups and items. These combinations are selected, which consists of, for example, here 7 times per week or once a day fortified cereals, and then 2 times a week liver, 2 times at least per week of banana, and 5 times per week of tofu, and 4 times of fortified snacks. And this give fulfillment of around 26 to 58% of the nutrient. In this example, which is for under 2-year-old, you can still see that some nutrients are still below 65%, and that is understandable when you have an absolute problem nutrient, because when you have absolute problem nutrient, actually you should be considering additional solution from the food basket, because partial problem nutrients, the solution are in the food basket. You can just improve the frequency of consumption, but for the absolute problem nutrients, you might want to expand the food basket to allow more solution. I will give example how this is done. So once you have developed, then you can make your IEC materials. An example here for this under 5 children in the stunting priority district. Together with our academic partners, including also UNDIP, we developed this GFR for under 2 and FBR for 2 to 5-year-old children. And in the message, the difference is that we highlight on the problem nutrients, and in the food-based recommendation, we also highlight the frequency per week of the specific nutrient-dense subgroup or food items to be consumed, along with the portions. And also highlighting the locally traditional recipes, which can be the vehicle for these nutrient-dense foods. So how do we put this into implementation or intervention, food and nutrient interventions? I give you example when we put it into the context where we promoted the complementary feeding recommendations that we have developed using LP in East Lombok, Indonesia. And this is the example of the GFR messages. This is in Indonesia, but the highlights are, since in this study we identify iron, zinc, and calcium as problem nutrients, we identified liver, fish, and anchovy as the nutrient-dense foods to be promoted, and we teach mother to make use of these 3 ingredients along with the minimum frequency per week, and we also teach them to make it more compact, more longer shelf life, like making it into shredded liver, fish, and anchovy. And we also teach them some recipes with this shredded liver, fish, and anchovy powder. And we also encourage, if they have to buy manufactured snack, but try to choose the fortified ones. And an example of how we try to solve the problem of the absolute problem nutrient, which is calcium, is that by introducing anchovy, because actually the anchovy is identified during our observation when one mother from the poor family actually managed to provide the child with the powdered anchovy, non-salted one. And they usually think children cannot consume anchovy because of the texture, but by making it into the powder, actually it is a smart way. And then we promoted the anchovy powder, and we promoted the recipes for the mothers to create. And then finally it really helps that simply by introducing the nutrient-dense food from the food basket of the adults member into the food basket of the under 2 children. And then this is an example how you can evaluate the results. Here an example of comparing the median intake of the nutrients between the intervention and control groups. And we also compare the dietary diversity score and found that it is higher among the intervention group. And we also you may also want to see, for example, whether the frequency of meat, fish, poultry, protein are higher in the group. For under 2-year-old, it is also recommended if you can also report the nutrient density, and this table shows that GFR developed with LP significantly improved the nutrient density, although for some nutrients still some challenge, but indeed the nutrient density are significantly higher for almost all nutrients. And then finally, additional function module that you can make use of this module in OptiFood is the cost analysis. And in this module of cost analysis, you can identify the lowest cost of nutritionally best diet for the target population. You can have information about what nutrient is actually most expensive, yeah, and as well as what foods are most expensive in the lowest cost nutritionally best. So to end, now that you know how to identify the problems and identify the solutions and compare alternative FBR or GFR using the LP, in addition, you can also make use of the informations once you establish the best combination, the selected FBR or GFR, and you find that there is still some nutrient gap remains, and we calculate nutrient gap can be a difference between 100% NRI versus the best diet, which will pick up the problem nutrients. Or you can also be more inclusive by looking into the difference between AR or 65% RNI with the selected alternative FBR, which will give you the highest gap and will pick both problem nutrients and dietary inadequacy. And with this nutrient gap, you might have further information to design complementary food and nutrient intervention. For example, it may not always be a fortification. It can be, for example, you might want to develop a food multi-mix using locally available nutrient-dense foods. So with this purpose, you can actually make use of another LP function available in NutriSurvey, and that can help you when you have some targeted nutrient requirements, nutrient levels in the recipe. For example, in the food multi-mix, then you have the candidate ingredients, and then you can ask the LP in this NutriSurvey to come up with the best combination of amount of the ingredients to meet a certain requirement of the nutrients. And we have done this for assessing how the current program using fortified biscuit, previously recommending 8 to 12 pieces per day, into a more reduced prescription of only 4 pieces per day, because we first optimize the diet of these under 5 children, and based on the optimized diet, we identify the gap which correspond to only 4 pieces of biscuit per day. And the result has shown that when children take this newly prescribed less dosage of fortified biscuit, the weight gain velocity is actually better. And this also at the same time promote a better dietary practices, which will not be the result if you focus only on the fortified products. And another also alternatives in the setting of workplace. For example, we also identify after developing the optimized FBR for the female workers in the night shift, we identified that some nutrient gap remains, and then we make use of this nutrient gap to enrich the food provided by the factory canteen. And so in 6 months, our intervention shows that the anemia has significantly been reduced in the intervention group by using the two approaches, the nutrition education to the women and the additional nutrient-dense food given during the factory meal in the factory canteen. And the last one is about how you can expand this LP approach for disease prevention. For example, we have now started to work with extended nutrients, so borrowing the column in the OptiFood for other nutrients like the PUFA, fiber. We have developed the FBR for women in reproductive age with dyslipidemia. And the final message recommend what needs to be improved, but at the same time what needs to be limited. And in the paper of Delmons, if you read this paper, it will also give an overview of the process of developing the FBR or GFR from collecting dietary data, the reference data, which is the food composition table, the RNI, and then defining the target group, importing the LP input data, until finally running the OptiFood module. So in summary, I have shown you the two sides that LP using OptiFood can help. First, to identify the problem, which is the problem nutrient, the dietary inadequacy, and the type of problem nutrient. At the same time, it also provides the solution side by helping us to identify the nutrient-dense foods and also nutrient gap if you want to design a complementary food and nutrient intervention, which will be just right, which will be not excessive, and which will be in line with the So in summary, you know how to make use of the LP approach now to identify the problem and the solution, to develop the FBR, GFRs, and FPDG, and also to make use of the nutrient gap information for complementary nutrition intervention. And based on the studies, you show that it is promising, it improves the dietary practices and nutrient intake, and of course we need more evidence which are how the improved intake can also lead to the improved nutritional status, especially at the level. So I thank you and wish you success in your future endeavor, and I hope this tool can be one of the important tools to accompany you in your further career, to be more specific, to be more targeted when you design a food and nutrient intervention. Have a good day, and thank you all for your attention.